Chapter number 1, Earth. We live on this earth along with billions of other animals, plants, and microorganisms. We human beings arrived on this earth about 1 lakh years ago. More than any other animal, human beings have been trying to make this earth a better place to live. We have been constantly trying to change ourselves, our surroundings. In this process, we have entered into the conflict with our inhabitants of Earth and amongst life. For long, we have looked at the Earth as a storehouse of resources which we can exploit and use at will. Gradually, we are realizing the fallacy of this viewpoint. Our recklessness, exploitation of the Earth has meant the destruction of forests, rivers, hills, fellow animals, and even fellow humans. This has resulted in what many are calling the environment crisis, like global warming and poisoning of our soils, water and oil. Today, more than any other time, we need to build a new understanding of the earth, how it works, and what we do on it, and what we do with each other. In class 6 to 8, you had studied about the diverse people living in different kinds of lands in different times, how they use the forests, soils, water, and minerals of the earth. In the following 4 chapters, we will study about the earth as a large interconnected system. We will see how the rocks, soils, and minerals, water, air, sunshine, forest, animals, and human interact with each other and change each other constantly. Why do you think people today are curious to know about secrets of distant stars and galaxies and the beginning of the universe? Initially, people thought that the earth was in the center of the universe and human beings the most important creature. What difference does this make to us to know what we are, a small insignificant speck in the vast universe? Read about the solar system and the planets that go around the sun in chapter 5, 10, Stars in the Solar System of Class 8 Science Textbook. Our universe, sun and the earth, thousands of years, humans have been looking into the sky and trying to understand what is surrounding. The stars remain fixed, which is rich as the sun, earth, which keep moving on across the sky. When people study these objects very carefully, noting down all the movements happening in the sky and trying objects very carefully, noting down all the movements happening in the sky and try to figure out what they are and how they move work initially. See on the next video you will see the galaxy and a lot of stars. Which is way just the sun, moon, earth, which keep moving on across the sky. When people study these objects very carefully, noting down all the movements happening in the sky and try to figure out what they are and how they move work initially. See on the next video. Now, Earth as a planetary body. Like all other planets in our solar system, the Earth rotates on its own axis and goes around the Sun in a definite orbit. The orbit is the path of the Earth around the Sun. The orbit is an uniform plane, which is called the plane of the orbit. Look these pictures of the Earth, Sun and orbit. Which one do you think is the correct picture? A circular path, an elongated oval path, a scaled oval path, Sun in the middle and 1.4 on other side and 1.5 on other side. Actually, the Earth's orbit is nearly circular, as in figure C, and the difference between Earth's farthest point, 152 million km, and the closest, 147, Earth travels at 107 kilometers per hour. At this speed, it takes 365.25 days to complete one revolution. We call this a year. You have studied in class 8 about the energy received by different parts of the Earth and Sun, and how this travel of the Earth around the Sun causes the seasons like winter and spring. Now take the factors which cause the formation of the seasons on the Earth. Daily rotation of the Earth on its axis. The word Earth, English word Earth, meaning ground, soil, dry land. Dictionaryonline.com, India languages have multiple words for Earth. Sanskrit terms include Bhumi, Prithvi, Dharni, Avani, etc. Many Indian languages use variations of these Sanskrit words.
Scientists are still debating how our Earth was formed. Most scientists are of the view that Earth began to form around 4.5 billion years ago. The Earth has reached its present form through several phases. It began as a ball of swirling dust and clouds, and passed through a molten stage. At that time the Earth was very hot and was constantly bombarded by massive rocks and other materials from the space. In this way the size of the Earth grew. The Earth was so hot that it was molten in hot liquid form. If you boil a thick soup containing many substances, you may observe that the heavier particles tend to go to the bottom and lighter particles come to the top. These lighter particles cool at the top and form a layer of crust like the cream of milk. Similarly, while heavier substances formed the part of the molten core, lighter substances rose to the surface and cooled. Slowly an upper crust of lighter and cooler materials formed, covering the molten interior. As the Earth's interior continued to cool, it contracted and the outer crust wrinkled, forming ridges, mountains, and basins, low areas which became oceans later. The atmosphere of the Earth consisted of different kinds of gases including water vapor. Most of these gases were such that life as we know it today could not have survived on it. It didn't have oxygen, which is necessary for us. It took a long time for the air we breathed to develop. The rain filled the great basins on the Earth's crust with water. Thus, the oceans were formed. For perhaps one half of the long span of Earth's history, the planet Earth remained barren and lifeless. Then life appeared in the oceans. It slowly evolved into diverse plants and animals, including human beings, over millions of years. Do you think the Earth was created suddenly, or do you think it was formed by long-drawn and complex processes? Some people believe that our being on this Earth is the result of a series of fortuitous accidents. It is quite possible that there may not have been any life on the Earth. Do you agree? Give your reasons. Internal structure of the Earth. Let us look at the internal structure of the Earth we live on. We can see the continuity from the early days of the formation of the Earth as we try to look deep inside the Earth. It took us years of scientific investigation and analysis of data to form an understanding of the interior of the Earth. The main reason for this is that even the deepest mines we have dug do not go beyond a few kilometers under the surface, while the radius or the distance to the center of the Earth is over 6,000 kilometers. The Earth is made up of three main layers: crust, mantle, and core. Crust. We live on the outer part of the Earth, which is called the crust. You saw in the last section how this layer was formed. This layer goes up to a depth of 30 to 100 kilometers. The crust mostly consists of various kinds of rocks. Mantle. It is 100 to 2,900 kilometers in thickness. The upper part of the mantle is a pliable layer over which the crust floats. This consists mainly of chemicals called silicates. Core. The core is 2,900 to 6,376 kilometers in thickness. It is composed of dense and heavy substances like iron and nickel. It can be divided into two sublayers. Inner core. The solid inner core, 5,100 to 6,376 kilometers of the Earth, is made up of iron compounds and heavy substances like gold. Interestingly, matter from deep inside the mantle shoots up through volcanoes and fissures on ocean floors and cools down to form the Earth's crust. In many regions on the Earth, part of the Earth's crust enters into the mantle and once again becomes molten. This constant process of formation and destruction of the crust explains the fact that our Earth is still very active. The crust on which we live is still being changed by earthquakes, volcanoes, subduction of land and rise of mountains due to processes happening deep down the Earth. Outer core, 2,900 to 5,100 kilometers, composed of liquid metallic material like nickel and iron. Movements of the Earth's crust. The shapes and positions of the continents may seem fixed at the time scale of human experience. However, when you look at how old Earth is, continents have moved, collided, merged, and then been torn apart. Again, mountains have risen and been raised to the ground, oceans have formed and dried up, valleys have been carved, and so on during the course of Earth's eventful history. In the early 20th century, a German meteorologist and geophysicist, Alfred Wegener, introduced the theory of continental drift to describe and partially explain the present arrangement of continents and ocean basins. He postulated a massive supercontinent, which he called Pangaea, Greek for whole land, as having existed 220 million years ago and then breaking apart into several large sections. He suggested that these sections moved away from each other. Over millions of years, some continents collided with others. They are still moving around. Pangaea is a Hypothetical continent from which present continents originated by the drift of Mesozoic era to the present. Wade Jenner hypothesized that the supercontinent of Pangaea broke up to form 1. Laurentia, present North America, Greenland, and all of Eurasia north of Indian subcontinent, and 2. Gondwana land, present South America, Africa, Madagascar, India, Arabia, Malaysia, East Indies, Australia and Antarctica. These two blocks were separated by a long, shallow inland sea called the Kitize Sea. It took millions of years for the continents to reach the present shapes and positions on the globe. Even today many of the continents are moving very slowly, pushing each other. We will read this in greater detail in the next chapter. The Earth's grade system. So far we saw the process of the formation of the Earth and its internal structure. Now we will see how it is shown on maps and globes. Using an atlas to find latitude and longitude of places. You can find the latitude information in a well-produced atlas or online using Google Earth. Here is one example of how to find the latitude and longitude information in the back of the atlas, where places are listed alphabetically, similar to the way words are listed in a dictionary. Example: find the latitude and longitude information for Kobe. Find the place name, Kobe, in the list. Next to that, you will find information about that place. This is a typical atlas listing. The atlas you use may present the information slightly differently, but these elements will be there. Do you know? The crust forms only 1% of the volume of the Earth, 16% consists of the mantle, and 83% makes the core. The thickness of the crust is just about the thickness of the shell of an egg. If we assume that the size of the Earth is equal to the size of an egg, we cannot hope to travel to the mantle to study it, but we can study substances from the mantle. Can you tell what these substances would be and how we can get them? With the help of the above maps, complete the following table. Hemisphere continents: Northern Hemisphere and Western Hemisphere, Southern Hemisphere and Eastern Hemisphere, Northern Hemisphere and Western Hemisphere, Southern Hemisphere and Eastern Hemisphere.
This is longitude and latitude, where you can find the longitudes being the semicircles, full circles. You can find the longitudes of our Mount Everest somewhere at the longitude in this direction, and latitude is in this direction. When we both join them, we find the location as Mount Everest, marked as red on the blue globe.
Longitudes Latin gives us the word longitudo, meaning length, from which we get longitude. Longitudes show us the length or height of a map. Longitudes are not full circles. They are semicircles connecting pole to pole. Every longitude cuts across every latitude. The longitude that passes through the Astronomical Observatory at Greenwich, England, is called the zero meridian, prime meridian, or Greenwich meridian. Greenwich, though it is spelled that way, is pronounced Greenwich, with accent on Gren. Several countries tried to fix a longitude that passes through their own territory as the zero longitude. However, England decided that the Greenwich meridian will be the zero longitude. They ruled a large part of the world at that time, so everyone else ended up following their system. There are 360 longitudes. We organize the main longitudes into two groups: 0 to 180 going east, which are the east longitudes, and 0 to 180 going west, which are the west longitudes. 0 and 180 longitudes do not have direction markers. Other longitudes have direction markers. For example, 2080 for 28 east longitude, 127W for 127 west longitude, and so on. Each degree of longitude, just like a latitude, can also be divided into minutes and seconds. The longitude 180, directly opposite to zero longitude, is called the anti-meridian. Anti means opposite to the east longitudes form the eastern hemisphere, and the west longitudes form the western hemisphere. After all this, remember, latitudes and longitudes are imaginary lines. Longitude and the question of time. It takes 4 minutes for the sun's position to move 1 of longitude. This means that the time is different for each degree of longitude. Here is an example. When the sun is directly overhead at any longitude, the local time is 12 noon.
Latitudes. The horizontal circle that goes around the Earth exactly in the middle at equal distance from North and South Pole is called equator because it divides Earth into 2 equal parts. This is a circle designated as zero latitude. Following the way angles are designated in geometry, latitudes are expressed in degrees, minutes and seconds. In many atlases, you will not find the minutes and seconds. Look at the figure 1.5. From the equator going towards the poles are a series of parallel circles. Each circle is called a latitude. Latitude comes to us from Latin word latitudinal, meaning width. These lines show us the width of the map. Latitude values range from 0 degrees equator to 90 degrees north, the North Pole, and 90 degrees south, the South Pole. There is no latitude less than 0 degrees nor greater than 90 degrees. Every latitude must be designated with direction N for the north and S for the south. For the equator, there is no north or south designation. Some latitudes are given special names. These are related to the patterns of sunlight falling on Earth that you would have studied when you learned about the seasons and Earth's revolution around the sun. The equator is the largest among all the latitudes. All the latitudes on either side gradually become smaller towards poles. At the poles, the 90 degrees north and 90 degrees south are not circles at all. They are just points. The half of the Earth between the equator and North Pole is called Northern Hemisphere. Hemi means half, hemisphere means half a sphere. The half that is between the equator and South Pole is called the Southern Hemisphere. Counting from one pole to another, there are 180 main latitudes, not counting the equator.
11:56 a.m. anti-meridian, at 9 a.m. 12:04 p.m. post-meridian, at 11 obviously. This can cause a lot of confusion. Therefore, the world is divided into 24 time zones starting from the Greenwich meridian, going east and west. The width of each time zone is 15 of longitude. This means the difference between one time zone and the next is 1 hour 15 of longitude x 4 minutes per longitude equals 16 minutes. As you go east from Greenwich meridian, you add time. As you go west of the Greenwich meridian, you subtract time. When it is noon 12 in the day, on Monday at 0 longitude, it is midnight 12 night. At the opposite longitude, the anti-meridian, just to the west of 180, the Tuesday is just beginning, while to its east Monday is just ending. Notice that if you follow the calculated time zone boundaries, some countries would have more than one time zone with less than 1 hour division. For example, India would have 2 half-hour time zones. That means the time between western and eastern parts of India would be different by half-hour, with the far-flung northeast even more different. This is considered too complicated to be useful. In such situations, some countries choose the time along one of the meridians that pass through their territory and follow the time of that meridian for the whole country. This time is called Standard Time. For India, it is Indian Standard Time East. For Pakistan, it is Pakistan Standard Time, and so on. The advantage of this is that in India, for example, wherever you are, it is the same time. In countries which span a large number of longitudes, keeping time is more complex. They may divide their country into more convenient time zones, usually with 1 hour difference between one time zone and the next. Other names, latitudes, are also called parallels because they are parallel to each other. Simple. Longitudes are also called meridians. We get meridian from the Latin meridianus, meaning noon, that is when the sun is directly overhead noon at a given longitude. So, longitudes are related to time and travel. You know that the Earth rotates on its axis, and longitudes are imaginary lines we have made. Hence there is a difference in the time as you travel from east to west or west to east. When you are traveling east to west, you gain time of 4 minutes as you cross every longitude. But if you are traveling from west to east, you lose 4 minutes as you cross every longitude. These are referred as EG and WLS. EG east gain, add, WLS west lost, subtract. Do you know? To avoid confusion of time from place to place, 823rd eastern longitude is taken as standard meridian of India and serves as the Indian Standard Time. The exact difference between Greenwich and East is 5 hours.
Using your atlas, find out how many standard time domains these countries have. USA, Australia, Russia, Japan, Zimbabwe, Chile. Swati works for a call center in Hyderabad. Her clients are in USA. She answers clients' questions about the computer problems. She always works during the night. Why is this? Use geography to find out. So, tease your brain. When it is 12 in the noon, in Greenwich, that is 0 degrees, which is the local time. At Mumbai, 73 degrees east, Chicago, 87 degree, 30 minutes west, Sydney, 151 degrees east. You see, here we have got the time domain of the whole world. So United States of America holds 1, 2, 3, 4 and 5 and 6. 6 different time domains. In India, it is withheld with only one time domain. So like this, every degree in the globe, which actually covers 4 minutes during the day and night. So the earth moves 1 degree in 4 minutes. Now that we have got some questions, look at the map of India in an atlas and identify the latitude and longitude for the following places: Kanyakumari, Imphal, Jaisalmer, Pune, Patna. Next question, identify the words that match with the latitude and longitude, parallel lines and vertical lines, horizontal lines. Look at the world map of time zone in text 30. If you travel from Vijayawada to Paris, to which time zone you are moving? If you are traveling from Hyderabad to Tokyo, which time zone are you moving? Why is it difficult to study the formation of Earth and its structure? Read the paragraph under the heading of internal structure of the Earth and answer the question, how can you say the Earth is still very active? So answers are on the screen. Just guide yourself to look at these answers and conclude them in your textbooks. Some more questions. What is the grade and how does it help? Differentiate between local and standard time, equator and prime meridian. If every state follows its local time, then what problems will arise? Again, answers are in hidden format. You have to dig it out and write it in your notebook. Question number 9. With the help of your teacher, Find out the standard meridian of given countries: Nepal, Pakistan, Bangladesh, England, Malaysia, Japan. So my dear friends, you by now have definitely got to know how to find out latitudes and longitudes. Longitudes are the longer lines which cross across South Pole to North Pole, and latitudes are full circles covering the spherical part of the globe. Okay, if you want to calculate the longitude, then observe the center of the earth, then take the location of the place for which you want to calculate, and from the 0 degrees you calculate how much it is towards the north or towards the south. The degrees will be measured from the baseline. And if you want to calculate the same for the latitude, latitude will be also calculated from the center and how much it has crossed itself towards east or west, it will be calculated. Thank you very much.